Hello, everybody, and welcome back. Today we are continuing our conversation about threats to our fresh water supply. So far we've talked about the kind of negatives of groundwater depletion. So what happens if we pull too much water out of the ground? We know that we can get things like saltwater intrusion and also land subsidence, which is not something we want. But today we're going to continue that conversation talking specifically about pollution in our waterways and also talking about this concept of eutrophication, which is something we do have to know about. So let's go ahead and jump in and use these notes to fill in the pages on our interactive notebook. So this is kind of a breakdown of the threats to our water supply. So fresh water is our most precious natural resource because we have to have it to live. We cannot live without water. And our demands for that water are enormous. We need it to brush our teeth and to cook and to drink and to do our laundry. And it's also extensively used in both agriculture and industry. Groundwater supplies most of that. Okay, so that groundwater that we talked about that you pump up out of the ground, it is what supplies most of our fresh water that we rely on a day-to-day basis. And this chart here gives us a breakdown of what we use fresh water for, and this was in 2005, so it was a while ago. This is probably actually around the time some of you were being born. But the percentages probably work out to be roughly similar today. So thermoelectric generation, irrigation, that's for agriculture, domestic and residential use, that's basically for your home. Public and industrial use, aquaculture. Aquaculture is just farming fish, mining, and livestock as well. So all of those things are what we use our water for. So this is the freshwater usage. Thermoelectric generation and irrigation. Irrigation is supplying for basically like farming and things of that nature, and then also using water to help generate electricity as well. So this is just a kind of a recap of overuse, but we are pumping out water from the ground quicker than it can be recharged, and to recharge just means to allow the water table to fill back up. So if the groundwater is pumped out at a rate greater than the recharge rate, the groundwater supply will decrease and the water table itself will drop. So remember, this is a depiction of a well that is heavily pumped. So we've got our water table up here, and we are overly pumping this well, which creates this cone of depression. And around this cone of depression, if it dips too low, the well can run dry, and overall, our overall water table can dip as well, which is not good. Subsidence, as a reminder, is just when we withdraw too much groundwater, it can cause the land to sink. And again, there's an example with the Leaning Tower of Pisa, and also this somebody's home which has kind of collapsed into a sinkhole, which would be devastating. Couldn't imagine my house just kind of falling into the ground. All right, so now let's talk about water pollution. We've talked about groundwater depletion and subsidence already, but what is water pollution? So anything that is undesirable in the environment or contaminates the environment is known as pollution. So when we talk about water pollution, these contaminants are going to be directly in the water. And a pollutant is any substance that disrupts the Earth's geochemical cycle. So anything in the earth that is not natural, that should not be there, that can cause issues. So there are two broad categories of point source and non-point source pollutions. So if something is said to be a point source pollution, you can identify exactly where it's coming from. So like you can point directly to the source and say the pollution comes from here. This first example is this pipe that's spilling into the waterway. This is a point source of pollution. We say, yes, that pollution that's being spilled into the water is directly tracked back to this pipe. We can see it. We understand that it comes from one source. Non-point source pollution is pollution that comes from a variety of sources. And a lot of times an easy way to tell the difference between point and non-point source is to look and see if the word is plural. So if like it tells you that the pollution comes from farms or croplands or factories with an S. It just means that you can't really identify which farm it comes from or which factory it comes from, and it's coming from multiple sources. In this image, we have an area. This is probably going to be a heavily farm, like a farm heavy area. There's a lot of people with different farms out here. What happens is that all these farms are along this river, and they all have pollution. They pollute with pesticides and herbicides and fertilizers on their crops. And when it rains, all of that pollution gets washed together. Okay, it gets washed together and it gets washed into this waterway here. Well, you can't really identify which exact farm that pollution came from because they're all contributing to the pollution. So it's a non-point source. The most common sources of groundwater pollution are sewage, industrial waste, landfills, and agricultural chemicals. So these will enter the ground above the water table, and they are eventually flushed downward by infiltrating and precipitation, and they become mixed with our groundwater. So remember, our unconfined aquifers are more susceptible to pollution. In the highly permeable aquifers, all pollutants, including raw sewage, can quickly spread. Now, we don't want raw sewage in our drinking water or our fresh water because we consume it, right? I don't know about you, but I don't want all those bugs in my drinking water. So chemicals are dissolved or transported with groundwater in the form of ions and molecules, and they can't be filtered out. So we'll talk about water treatment and how we treat our water, but chemicals can't be filtered out because they're too small to see. You can't catch them with a screen. So once they have entered the groundwater, it's not easy to remove them. We'll talk about how we do get them out, but it's not an easy process, and it does take some money and some time to do. Now, this is kind of what we're talking about, or what our main focus is of the day, and this process of eutrophication, which is something that we absolutely positively have to know about and know the steps of. This is what our activity is going to focus on for the lesson as well. So eutrophication is a process that happens when mostly in a heavily farmed area where there's a lot of agriculture. And it's a natural process. It happens sometimes on its own, but it can really be sped up by having excess farm land in an area. So here's what happens, and I'm going to explain it. You might have to listen to it a couple times, but I'm going to take you through step by step. So step one, there are a lot of phosphorus and nitrogen nutrients in fertilizer. So all of these farms put the nutrients on their crops as fertilizer to help their crops grow. Great, awesome. We get our crops, we get food, we're happy. However, when it rains, all of the excess nutrients are washed into the water. So we'll just say that there's a river nearby and the nutrients get washed into there. So when those nutrients go into the water, there's algae in the water. And algae are also photosynthetic, just like our plants are. So the algae also really love the nutrients. So just like the fertilizer helped our crops grow, the fertilizer in the water is going to help the algae grow. So the algae eats and eats and eats all these nutrients in the water, grows and grows and grows. And so the water will look like scum. It's got a big old green algae patch on the top. So once that algae is on the top and you can see it with your naked eye, we're going to run into some problems. Okay, so the algae itself is not harmful to most fish. It's what happens after they die that is the problem. So eventually, you can get too much of a good thing, and when those nutrients run out, the algae stop growing because, well, there's no more nutrients for them to eat and they can no longer multiply. So once the algae and the nutrients are gone, the algae starts to die. Okay, so no more nutrients, no more algae. The algae have to die. Well, when the algae die, the algae bodies are just floating around and taking up space in the ocean, or not the ocean, the freshwater system, the lake. So if the algae bodies are just floating around, they have to go somewhere. And that's where bacteria come into play. So bacteria, they are decomposers. Okay, so their job in their ecosystem is to break down organisms that have died. Well, the bacteria in the water are going to break down the algae bodies, because that's what they're supposed to do. That's their job. They're going to break it down and they're going to carry those bodies and they're going to clean up the waterway so that it's clear again, which is also good because that's their job. But here's the problem. Those bacteria have to have oxygen in order to break down the algae. And what that means is that the bacteria have to take the oxygen from the waterway. So they get their oxygen from the dissolved oxygen that's in the water. So the bacteria are doing what they're supposed to do. They're using a lot of oxygen in order to break down the algae that has died. But what happens is that because the bacteria are using up all that oxygen, the fish do not have it in order to live. So you get these areas called hypoxic areas, which means low oxygen. And if there's low oxygen, fish can't live there because just like you and I need oxygen to live, fish do as well. As the fish swim through the water, the oxygen passes through their gills and it is carried to their organs, kind of the way that we do when we get oxygen from breathing in through our lungs. So algae blooms because of the excess fertilizers, algae dies, bacteria break down the algae, which then lowers the oxygen in the water because the bacteria is using all that oxygen up. I know that's a long process and kind of step by step, but we're going to be doing an activity to help us kind of visualize that as well. Okay? So, what kind of things can we do to help stop pollution and how can we conserve water? So, that's just something to kind of end off and think about. Some ways that you can help stop pollution is making sure that you are recycling and you're not tossing things out the window, right? Don't flush your medications down the toilet. Some people do that. Do not flush chemicals or medication down your toilet because that will eventually have to get treated and be pulled out. And then ways to conserve water. If we're talking about the conservation of water, meaning limiting our water use, you could turn off your faucets when you're brushing your teeth, or cut down on the number of minutes that you're in the shower, or get high efficiency appliances when you get older and are able to choose kind of what goes into your house. There are lots of the ways that we can do to kind of protect our ecosystems and also help conserve water. Also, you can use gray water, which is water from sinks or rain that's used in landscaping. So if you have a garden or your parents have a garden, you can actually collect rainwater and use that to water your plants. You have to be careful about that because within some city limits, you are not allowed to collect rainwater, which is kind of a racket, but be careful before you do that because some cities do have like limitations on that, and they say it's because it will attract mosquitoes, but I'm pretty sure it's just because they want you to pay for their water instead of conserving water and collecting your own. And then also, again, upgrading water purification and management systems can also help with conservation as well. Okay, so that's all for today. The biggest takeaways here are going to be about eutrophication and how we get hypoxic waterways. I'm going to help explain that a little bit more in class, or re-explain it in class as well, just so we're all on the same page. But it's really good to get that intro into it and know kind of the 411 on eutrophication before we get into class. All right, so that's all for this lesson. We will continue on as we go through Unit 4. If you have any questions, let me know. And if not, I will see you guys in the next one. Bye, guys.